All right, this is our lesson for 10.5b, and it is our last lesson or last new material for the year for Honors Algebra 2. So, um, how exciting. All right, I can solve same thing, linear and quadratic trigonometric equations. Today we're going to work on quadratic. So many trigonometric equations are quadratic. We will solve these equations in the same way that you have solved other quadratic equations. Once each of the trigonometric expression is isolated, we will use this unit circle to find angles making the equation true. And we will be paying attention for extraneous solutions. So here we go. Find all the solutions on the interval of 0 to 2 pi. I should make sure to note that we have a bracket on 0 and we have a parentheses on 2 pi. And we have an interval of 0 to 2 pi, but 2 pi isn't included in that because 0 is, and 2 pi is located at the same location. So it's a bracket. I'm sorry, it's a parentheses. So this is our interval. That means we're in radians. So, and this is going to be exact answers. It should have said exact. If it says exact answers, then we have to use fractions. We can't use our calculator, so to speak, okay? All right, so here is my equation. I have 2 times sine theta minus 2 square root of 2, and I have cosine theta plus 4, and those two multiplied together equals 0. So either this portion is equal to 0, or this portion is equal to 0. And I can solve by setting 2 sine theta minus the square root of 2 equal to 0 and find the values of theta that make that true. And I can set cosine theta plus 4 equal to 0 and find the values of theta that make that true. Now we're basically what we did yesterday. And so the first thing I'm going to do is get square root of 2 over on the right. So I'm going to add it to both sides of my equation, and I get that. And then I'm going to divide both sides by 2, and I will get square root of 2 over 2. Now, this is where my unit circle comes into play. And I'm thinking to myself, where on my unit circle is sine the square root of 2 over 2, or what angles of theta does my sine equal square root of 2 over 2? Well, sine is associated with my y value. This is a positive, so I know that this is located at my 45 degrees, and I have another one that's equal to my 45 degrees as well, but it's on the second quadrant. This is pi over 4. This is 3 pi over 4. And if you need to refer to the unit circle on the previous lesson, you can do it and you will be able to find those values, okay? The better you know this by heart, the faster and more efficient you're going to be. So I know for a fact that theta is equal to pi over 4 and 3 pi over 4. Now let's go and see what else it's equal to. I need to then subtract both sides by -4, and I get -4. And I have to find where on the unit circle does my x value, this is cosine, does equal -4. Well, that's outside of my unit circle, so this is no solution. And so therefore, these are my only answers. Let's clean that 3 up. That is 3 pi over 4. All right, how about the next one? I have tangent x times, in parentheses, 2 cosine x plus 1 is equal to 0. So either tangent x is equal to 0, or 2 pi x plus 1 is equal to 0. And then I can set each one of those individually to 0 and solve. So tangent x is equal to 0. Where is tangent equal to 0? Well, tangent is y over x. So I need to find where my y value is equal to x on, I'm sorry, my y value is equal to 0 on pi as an answer. So x is equal to 0 and pi. Now I'm going to solve 2 cosine x plus 1 is equal to 0. I'm going to subtract both sides by 1, and I get -1. I'm going to divide by 2, and I've got -1/2. So where does -1/2, I'll put this in red, where is my x values on my unit circle equal to -1/2? Well, -1/2 is my short side of my circle, so it's going to be up here and here. That is my 6.3 pi over 3 angles. So this is 4 pi over, nope, 2 pi over 3. Still memorizing it myself. 2 pi over 3. And this is 4 pi over 3. Let me double check my answers. Yep, that is it. So if you need to refer back to the unit circle, go ahead and do that. Now I have 2 pi over 3 as an answer and 4 pi over 3. 2 pi over 3, 4 pi over 3. Why don't you try one yourself? Welcome back. I know that what's in parentheses here is equal to 0, or tangent theta minus 1 is equal to 0. So I have 2 sine theta minus 1 is equal to 0. I'm going to add 1 to both sides. I'm going to divide both sides by 2. Sine is equal to 1/2. Let's go ahead and take tangent theta minus 1, set that equal to 0. Add 1 to both sides. Tangent theta is equal to 1. Now that one, okay, well, let's do sine first. Sine is my y values. That means my y values are my short side of my 30, 60, 90 triangle, and it's positive. So my y values is my short side of my 30, 60, 90 circle, and it's positive. My short side of my 30, 60, 90 circle, and it's positive. That is my pi over 6 angle here, and this is 5 pi over 6 here. So that one is my sine theta is equal to 1/2. My angles are theta is equal to pi over 6 and 5 pi over 6. Tangent theta is equal to 1. That means my y divided by x is equal to 1. Well, there's only one location where my y and x values are the same, and that's at my pi over 4. And that has to be in either positive and positive. So we would have square root of 2 over 2, square root of 2 over 2 there. And so that is my pi over 4. And then also over here in the third quadrant where I have negative square root of 2 over 2 and negative square root of 2 over 2. And that is my, I think, I'm still learning them myself. So that is my 5 pi over 4. Double check my answers. Yep. And so here are all my values of theta that make this true. Pi over 6. 5 pi over 6. That's my sine of theta is equal to 1/2. And then I have pi over 4 and 5 pi over 4. Okay. Hope that's starting to make sense. Now, we have a quadratic expression. Those were also quadratic expressions. They were just already factored form for you. We have cosine, for cosine squared of x minus 1. There's 2 different ways to solve this. The first thing you can do is go ahead and isolate your cosine squared of x. And I can do that by adding 1 to both sides of the equation. So 4 cosine squared of x is equal to positive 1. Divide both sides by 4. So cosine squared of x is equal to 1/4. How do I get rid of the squared? I'm going to take the square root. And so the square root of cosine squared of x is equal to cosine of x. And this will be equal to plus or minus the square root of 1/4. fourth, which is equal to 1/2. The other thing you could have done was actually factored this, because it is the difference of two squareds, and it would have been 2 cosine minus of x, sorry, of x, yes, minus 1, and 2 cosine plus 1, and that is equal to 0. You would have solved that, and you would have found that cosine of x is equal to, again, plus or minus 1/2. Okay, so again, what's on the unit circle, where I have values of cosine, those are x values on the unit circle that are positive and negative 1/2. 1/2 on my 30, 60, 90 is my short side, so across from 30, and across from 60 is my square root of 3/2, that's my long side. And so I need x values that are my short side. So here's a positive 1/2, here's a negative 1/2, here's another negative 1/2, there's a positive 1/2. That is my short side of this triangle. So that x value is going to be across from my 30-degree angle, and this inner angle is 60. That is my 643. That is my pi over 3 angle. This will be 2 pi over 3. This will be 4 pi over 3. This is 5 pi over 3. And again, you will have a unit circle, so you can go up to this circle and confirm that that is where those answers were. So I'm looking for positive and negative halves in my x value. But the sooner you learn your unit circle, the better, the more efficient you will be. So my answers for x are what angles of x, what values of x that make this equation true. That will be pi over 3, 2 pi over 3, 4 pi over 3, 5 pi over 3. All right, the next one. I have secant squared minus 2. I'm going to isolate my trigonometric function. I'm going to add 2 to both sides of the equation. I will then find that that is secant squared is equal to 2. I'm going to go ahead and take the square root of both sides. I get secant, there should be a theta in there, excuse me. I get secant of theta is equal to the plus or minus the square root of 2. I don't want to deal with secant. I know that secant is related to cosine, so I'm going to change that to cosine, and that will be the reciprocal of what I had before, which is plus or minus the square root of 1 over the square root of 2. I'm going to get this radical out of the denominator by multiplying the top and the bottom by the square root of 2, and I will find that to be plus or minus the square root of 2 over 2. So now I got to look at my unit circle and determine what angles have an x coordinate such that they are square root of 2 over 2, both positive and negative. That happens at my 45-degree triangles, and both positive and negative. So I have 4 locations. Those are at pi over 4. That is at 3 pi over 4. This is at 5 pi over 4. And this is at 7 pi over 4. If you need to, refer to your unit circle from yesterday's lesson to find where those values for x are. Please feel free to do that. So my answers for this particular problem is theta is equal to pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. And that was be the answer. All right, you have one yourself. Go ahead and pause the video and give it a try. Welcome back. You could approach this 2 different ways. You could have isolated the cosecant squared and solved it that way. That is actually my preference. If I can, I will do that. Cosecant squared of theta, I'm going to add 4 to both sides, and then I'm going to take the square root of both sides, and I will find that the cosecant of theta is equal to plus or minus 2. Don't forget that plus or minus. Let me make that cleaner. Is equal to plus or minus 2. You could have also factored. This is a difference of 2 squares. So this would have been cosecant theta minus 2 times cosecant theta plus 2 is equal to 0. Set each one of those individually equal to 0 and solved, and you would have found the exact same answer of cosecant theta equal to plus or minus 2. Okay, don't like working with cosecant. That is related to sine. So I'm going to go ahead and convert that to sine, and that will equal plus or minus 1/2, which is the reciprocal. Now I need to go find where on my unit circle do I have angles such that my y-coordinate is positive and negative 1/2. So if I draw my unit circle, whoops, that's a terrible unit circle. Here we go. I need positive and negative 1/2. 1/2 is the short side of that 30, 60, 90. So I need a positive short 1/2, positive 1/2. I need negative 1/2, and I have negative 1/2. Those are my pi over 6 angles. This will be 5 pi over 6. This is 7 pi over 6. And this one is, I have to think about that one, 11 pi over 6. Let me double check my answers. That is correct. So theta equals pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Okay. Hope it's starting to make sense. Again, I put together a video on the unit circle and just need to encourage you to continue to work with the unit circle. Make sure you understand all of the angles in radians and the X and Y coordinates at those your 30, your 60s, and your 45s in each quadrant. All right, I have another problem that I need to solve. And even though this looks hard, I want you to imagine this equation in this particular light. This is the same as a squared plus 3 times a plus 2 equals 0. And a is just the sine of x. So sine of x squared plus 3 times sine of x plus 2. And if that is my equation, I can factor this. I need 2 numbers that is multiplies to 2 and adds to 3. So plus 2 plus 1, and then I have a and a. And the issue is that a is equal to sine of x. So I'm going to go ahead and write that. And I have sine of x plus 2, sine of x plus 1, and that is both equal to 0. Either sine of x plus 2 is equal to 0, or sine of x plus 1 is equal to 0, and I can then use that to solve for values of x that make those 2 statements true. So let's do the left one first. So I'm going to subtract 2 from both sides of the equation, and I will find sine of x is equal to negative 2. Let's go ahead and do the other one. I have sine of x is equal to negative 1, and yes, that is all I've got. Where on the unit circle is my y value, negative 1 or negative 2? Well, negative 2. Farthest y gets is negative 1, negative 2 is out here, so this is never. There's no solution for that. How about negative 1? Well, that happens at, well, this is 0 pi, this is pi, this is 3 pi over 2. Yes. Okay, so the values of x that make this true, what angles? That is 3 pi over 2. And that is the only solution. How about B? This is a similar situation. I have something that looks like 2 times a squared plus 3 times a minus 2 is equal to 0. The only thing that a is secant. So let's go ahead and figure that out. I have what multiplies to, well, we got two coefficients, so I have to multiply the 2 and the 2 together, the -2 that is. So I have what multiplies to -4 and adds to a +3. What two numbers multiply to -4? That would be a +4, and so let's go ahead and do that. So I'm going to have to keep that 2. I have a +4 and a -1, and now I need to divide by that coefficient, which divides out nicely on this side of the equation. And so when I factor that, that gives me a plus 2 times 2a minus 1, except a is the secant. And so I'll go ahead and fill that in. I have secant x plus 2, and I have 2 times secant x minus 1 is equal to 0. All right, let's solve each one of that, and I will find that secant x equals -2. Secant is related to cosine, so I have cosine of x is equal to -1/2. Over here, I will solve that for secant x equals, move the 1 over, and I will have 1/2, and then I need to make that a cosine, and I will have cosine equal to 2. First off, cosine is my x value on the unit circle. This will be can never be larger than 1. Then cosine of x is -1/2. So where is that possible? This again is my x value on the unit circle. It's going to be negative, and it's the short side of my triangle. So it can't be here because that's my long side. That's where my x value is square root of 3/2. So I've got to be here and here. Those are my 6, 4, 3. That is my pi over 3. And this is my 4 pi over 3. So x is equal to pi over 3 and my 4 pi over 3. Again, you will be given a unit circle, but it's really good if you can start trying to understand where those are on the unit circle. Uh-oh, I made a mistake. This is 2 pi over 3. Pi over 3 is over here. Sorry about that. Yes, 2 pi over 3 and 4 pi over 3. Okay, one more to go. Your turn. Go ahead and try this one after pausing the video. Okay, welcome back. This is going to, I got to find two numbers that multiply to 2 times -4, -8, and add to a -7. That's going to be, did I do that right? All right. That is going to be, I'm going to go ahead and assume this is a squared and this is a. So I have 2a and a, 2a, I'm sorry, and then -8 and add to a -7. So I'm going to have a -8 and a +1, and I have to divide all that by 2. I'm going to divide that on the right hand side. So I'm going to have 2a plus 1 times a minus 4. I'm going to go ahead and plug in what a is, which is cosine. So 2 cosine of x plus 1 times cosine of x minus 4, and all of that is equal to 0. Either this equals 0 or that equals 0. We're going to set those equal to 0 and solve. So 2 cosine x plus 1 equals 0. I'm going to solve that and find cosine of x is equal to -1/2. Then I'm going to solve the next one, which is cosine of x equals 4. This will never happen because this cannot, cosine is my x value, x at the maximum is at 1. Where on the unit circle is cosine -2? I'm sorry, -1/2. That is my x value. 1/2 is my short side of my circle, and that is going to be up here and here. Again, that was actually what we just did, I think. Yep. This is 2 pi over 3 and 4 pi over 3. So x is equal to 2 pi over 3, comma, 4 pi over 3. All right, real quick, you don't have to watch this. Here's my unit circle again. I'm going to just go over it one more time for my online students. There's all my 30, 45, 60, 30, 45, 60. So I have my 6, 4, 3, 6, 4, 3. Those are going to tell me my denominators. So this is going to be pi over 6. This is going to be pi over 4. This is going to be pi over 3. We know this is pi over 2. This right here, we're going to subtract 1 on this side. Let me go ahead and write that out here. We're going to use this subtract 1 for the fact that we're going to help us determine the numerator. So I know I'm over 6. I'm going to subtract 1 from 6. I get 5. That's my numerator. I know I'm over 4. I'm going to subtract 1 from 4. I have 3 pi. I know I'm going to have a 3. I'm going to subtract 1. I get 2 pi. Okay. Over this side, I have plus 1. This is 6, 4, 3. I know I'm over 6, but I have 7 pi. I know I'm over 4, but I have 5 pi because I added 1. I know I'm over 3, but I have 7. No, I have 4 pi. 4 pi over 3. Okay. Over here, I have 6, 4, 3. I start from the x-axis and move in that direction. Now what I do is I look across and I say, okay, I'm going to take 5 pi over 6. I'm going to multiply by 2 on that top one. That'll be 10. I'm going to add 1. That's 11 pi over 6. I'm going to do the same thing on the over 4. I see I have 3 in the numerator. I'm going to multiply that by 2. That's 6. I'm going to add 1. That's 7 pi over 4. And lastly, this is, whoops. I have pi over 3s, and I look at the numerator on the cross from that. It's 2 pi. I'm going to multiply by 2. That's 4. I'm going to add 1. That's 5 pi over 3. Now, just real quick on the short and long. So this is my right triangle. I notice this is my long side. So that's my x, and my short side is my y. The long sides are going to be square root of 3 over 2. My short sides are going to be 1/2. Pi over 4s are equal distances. That's the square root of 2 over 2. Again, I have a 30, 60, 90. My short side is my x, that's 1/2. My long side is square root of 3 over 2. Then I have over here, I have a negative x value, and it's my short side. So that is negative 1/2. And my long side is my y, which is square root of 3 over 2. Okay. And then I would keep filling that in all the way around. These will all have negative x values in quadrant 2. Quadrant 3 will have negative x and y's. Quadrant 4 will have negative y's and positive x's. Hope that makes sense. Again, keep working on your angles so that you can understand where you're at. I think that I know you don't have to memorize it in this class, but I personally think it will help you be more efficient and more confident in your work. Congratulations on completing all your new material for Algebra 2 honors.